Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and in this video, we'll break down an advanced problem that involves transformations of functions and some critical thinking skills. We encourage you to pause the video and try the problem first. Then press play when you want to see how we approach the entire problem. So, we're given the graph of the function f of x. So note that a here does not equal to 0, so that it is not a constant function. And n is just some natural number. And we perform the following transformations on it. So the first one is we stretch it vertically by a factor of 3. And then we reflect it in the y-axis. Then we horizontally stretch by a factor of 2. And then the fourth transformation is to translate it left by 2 units and up by 5 units. So now, after that transformations have happened, these are the 3 new points, and note that these are the points on the new graph. So we want to determine the equation of the original function f of x and the equation of the new function after the transformations have been applied. So what this means is that we need to reverse engineer the entire process to get the 3 points that were on the original graph. So in order to do that, we need to perform the 4 transformations, but in reverse order, as well as in the opposite direction. So let's go ahead and write down those first. Okay, so the first one, which is actually the fourth one. So the last transformation that was done is to go left by 2 units and up by 5 units. So then to go in the opposite direction, that means we're going to translate 2 units to the right and then 5 units down. Our second transformation, that's going to correspond to the original third transformation. So originally, we were stretching it horizontally by a factor of 2. So now to do the opposite, we need to horizontally stretch by a factor of 1/2. Okay, and now the third transformation, which was originally the second transformation, that was reflected in the y-axis. So doing the opposite is still reflecting in the y-axis. So reflect over y-axis. And then the fourth transformation, which was originally the first one, that one was stretching vertically by a factor of 3, which means to do the opposite, we're going to vertically stretch by a factor of 1/3. Okay, so now we have the transformations needed to get those 3 points back to where they were on the original graph. So let's go ahead and perform those 4 transformations on those 3 points. So let's move this down a little bit, and then we'll write down the transformations of the points right beside it. Okay, so the first point that we're transforming is -8, 133 over 2. Okay, so translating that 2 right, 5 down is going to give us -6, 123 over 2. Stretching it horizontally by a factor of 1/2 is going to give us -3, 123 over 2. Reflecting it over the y-axis means the x is going to change sign, so that's going to be +3, 123 over 2. And then vertically stretching it by a factor of 1/3 is going to give us 3, 41 over 2. So this is the first point on the original graph. Now the second point is -2, -55. And we're going to do the exact same thing. So the translation will get us to 0, -60. The horizontal stretch will be 0, -60. The reflection over the y-axis will still be will still be 0, -60. And then the vertical stretch is going to be 0, -20. And then the last point is 2, -31. And again, we're going to perform the same transformations. So translation will get us to 4, -36. Horizontal stretch is going to get us to 2, -36. Reflection over y-axis will give us -2, -36. And then the vertical stretch will finally get us to -2, -12. So these 3 points are going to be the 3 points that were on the original graph for the function y is equal to f of x. So what we're going to do is we're going to substitute these 3 points into the original function. Okay, so how we're going to do that is take the x and the y value, put it into the original function, and then we're going to end up with a system of equations. So let's go ahead and do that. So recall our original function f of x was equal to a times x to the power of n plus k. So we're going to start with the first point. We have a y value of 41/2. So we get 41/2 is equal to a times, and then our x value here is 3 plus k. Substituting in the values for the second point into the function, we're going to get -20 is equal to a times 0 to the power of n plus k. And then doing the same thing for the third point, we're going to get -12 is equal to a times -2 to the power of n plus k. Notice for the second point, our x has a value of 0, which means a times 0 to the power of n, well, that's just equal to 0. So from this, we can actually see that our k value is equal to -20. So that means we can actually go ahead and substitute this k value into the other 2 equations. So let's go ahead and do that. So substituting it into the first equation, we're going to get 41/2 is equal to a times 3 to the power of n minus 20. Substituting it into the third equation is going to give us -12 is equal to a times -2 to the power of n minus 20. So now we have 2 equations with 2 unknowns. And there are multiple different ways to solve this. You can do it by substitution, but what we're going to do is we're actually going to take this first equation, and then we're going to divide it by the second equation. And the reason we want to do that is because they both have a there, and if we divide the first equation by the second equation, we can actually cancel out the a. So we're just going to move the -20 over to the left side first for both of these equations. So the first equation, if we add 20 to both sides, we're going to get 81/2 is equal to a times 3 to the power of n. And doing the same thing to the second equation is going to give us 8 is equal to a times -2 to the power of n. Okay, so now we're ready to divide the first equation by the second equation. So we'll take the left-hand side. So we're going to take 81 over 2, and then we're going to divide it by 8. So we're doing 1 divided by 2. So the left-hand side becomes 81 over 16. And then the right-hand side, a divided by a, that's going to go away. And then we're left with -3 over 2 to the power of n. So looking at this, we can actually solve this by inspection. So we actually get n is equal to 4. And now that we have the value for n, we can take this value for n and substitute it either back into equation 1 or equation 2 to solve for a. So we're going to do that for equation 2 just because it's a little bit easier. So taking this n and substituting it into equation 2 is going to give us 8 is equal to a times -2 to the power of 4. Now -2 to the power of 4 is going to be 16. So we end up with a is equal to 1/2. So now we have all the values of our unknowns. We have our a, our n, and our k. So let's go ahead and rewrite the original equation with those values in there. So we get f of x is equal to 1/2 times x to the power of 4 minus 20. Okay, so this is the first part of the problem because it was asking for the original function. Now, the second part of the problem is to find the equation of the new function after applying the transformations. So let's go back and take a look at what the transformations are. So it was these 4 transformations. So what we're going to do is we're going to write this in function notation and do it by replacement. Okay, so let's go back here. Okay, so the first one was a vertical stretch by a factor of 3. So that means we're going to replace y with 1/3 y. So we get 1/3 y is equal to f of x. The second transformation was to reflect it in the y-axis. So what that means is we replace x with -x. So we get 1/3 y is equal to f of -x. The third transformation was to horizontally stretch by a factor of 2. So that means we replace x with 1/2 x. And then the fourth and final transformation was a translation by 2 units to the left and 5 units up. So 5 units up means we replace y with y minus 5. And then 2 units to the left means we replace x with x plus 2. Okay, so now we can actually go ahead and take this and rewrite our new equation. So in order to do that, we're going to isolate y here. So we get y minus 5 is equal to 3 times f of -1/2 x plus 2. And then move the 5 over, and we'll get y is equal to 3 times f of -1/2 times x plus 2 plus 5. And now we can take our input here and put it into our function f. Okay, so that's going to give us y is equal to 3 times, and we have 1/2, and the x here is going to get replaced by negative 1/2 x plus 2 to the power of 4 minus 20 plus 5. Okay, and now we're just going to simplify this a little bit. So we get y is equal to 3 times 1/2 times negative 1/2 to the power of 4 is going to be 1/16. And then we have x plus 2 to the power of 4 minus 20, and then plus 5. Okay, and then we're going to distribute the 3. So that's going to give us 3/32 times x plus 2 to the power of 4 minus 60 plus 5. Okay, and then the final step, that's going to be y is equal to 3/32 times x plus 2 to the power of 4 minus 55. So this here is going to be the equation of the transformed function. If you made it to the end of that problem, well done. This was no walk in the park. Function transformations can feel a little bit overwhelming sometimes, but with a clear plan and strategy, they become totally manageable. I hope you enjoyed this problem here, and leave us a comment if you'd like to see more advanced problem on combined transformations in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.